Independent factorial ANOVA write-ups. Okay, so today we're going to look at how to write up the results of an independent factorial ANOVA. So like many of the other write-ups we've seen so far this semester, there are a few key components that we need to include in the write-up. So regardless of whether our results are significant and whether we have a significant interaction or not, we do need to include the type of analysis that was conducted and list the variables that were also included. We need a statement about our null hypothesis. We need the descriptive statistics for the groups being compared. And then depending on whether or not we have a significant interaction, we need to, in the case of a non-significant interaction, we need to talk about the model fit, so the F statistic for the two main effects, and then mention that the interaction was not significant. We need the effect size of both main effects. And finally, if one of our main effects has more than two levels, so for example, it's not a variable like gender where we just have males and females, but something more like course section where you have section A, B, and C. In that case, we would need to report the post hoc analyses in order to say exactly where the differences are on the two main effects. Now, and finally, a additional conclusion statement. When it comes to the significant interaction, we have a little bit more to report. So we don't care anymore about the simple effects, so you don't need to, not the simple effects, the main effects. So you don't need to report the F for either of the main effects, but you do need to report the F for the interaction. Then we need the effect size for the overall model. So now it's not just the main effects or the contribution of the main effects, but it's going to be the main effects plus the interaction. We need the results of our simple effect analyses. And then if at any of our simple effect measurement levels we have more than 3 groups, we need to also include the post hoc comparisons to see where the significant differences are. And then finally we need a conclusion statement. So lots to include, depends on the scenario. We'll look at an example right now with a significant interaction. Okay, so the research question was, do students from different programs, science, psychology, or engineering, and different genders, men or women, report different levels of well-being? So these were our results. If you recall, we had the mean and standard deviation for each of the cells. So we had the male engineers, the male science students, and the male psychology students. And then we had the same information for the female, the female engineers, female science students, female psychology students. And then at the bottom, we had the mean for each row, so just all engineering students, all science students, and all psychology students. And then here we have the mean for just men and just women. And then this here is the grand mean. So one thing I'm going to point out right now is when we are talking about simple effects and we're talking about reporting the descriptive statistics, we actually need to report the group means for each cell because we are breaking down the data cell by cell. So we need in our conclusion to report the male engineers, the female engineers, the male scientists, female scientists, etc. Whereas when we're talking about main effects, so in the case where we don't have a significant interaction, we are concerned more with the column and row means and standard deviations. So what that would mean is that if we did not have a significant interaction between program of study and gender, we would report the main effect for program and the main effect for gender. And when we'd be talking about which means are different, we would be talking about these means here for gender. So we'd compare males and females, and that would be for the main effect of gender. And then when we're talking about the different programs, we would talk about these means down here. So the mean for all engineering students, all science students, and all psychology students. So that's the case of a non-significant interaction, but in this current example, since I know it's an example of a significant interaction, we're concerned with the means of all the individual cells. So these were the results, that we had obtained from that analysis. So we can see here that we had, for the main effect of gender, an F of 8.19. For program, it was 38.93, and then the interaction was 1105. Sorry. Okay. I didn't put the critical values here, but for 1 and 12 degrees of freedom and 2 and 12 degrees of freedom, they're both smaller than these values, so we can actually reject the null hypothesis for the main effect for gender, reject the null hypothesis for the main effect for program, and then also reject the null hypothesis for the interaction. So that means that we're interested in this. If we were to calculate the R square for this plus this divided by this, we would have 0.9, which means that these variables and the interaction explain 90% of the variance in the dependent variable. Okay, so since we had a significant interaction, we also looked at the simple effects. So what we saw here is when we were looking at the differences between gender for just the engineers, we found there were no difference, so that's why we have an F ratio of 0. It's because both groups had the same mean. When we looked at differences in gender for science students, we got an F ratio of 30. And when we looked at the difference in gender for psychology students, again, we had an F ratio of about 0. This time when we looked at the difference by program for male students, we had an F ratio of 26.09. And when we looked at the difference by program for female students, we also had a large F of 23.9. So again, this value here and these two here exceed the critical value for 1 and 12 and 2 and 12 degrees of freedom. So in these three cases, we can reject the null hypothesis and conclude that there is a difference. So that means that there's a difference between male and female science students, and then a difference between males somewhere and a difference between females somewhere. And since we're not sure which program is different where, we had to do the post hoc analyses. And since we've done this by hand, we actually used the 2 key post hoc analyses or group comparisons. And what we saw with males is that there was a significant difference between engineering and psychology and science, but then no difference between engineering and science. Whereas with the female students, we saw there was a difference between engineering and science and engineering and psychology, but no difference between science and psychology. So if we go back to look at the means here, what our analysis basically found was that these were the same, but both of these were different from this, and then these were the same, and both of these were different from that, when we're looking at just males, just females. And then when we looked at just these two here, there were no difference, which makes sense, they're the exact same. And here as well, there was no difference. It was too small to be significant. However, when we looked just at science, we saw here that these two were different. So that is the summary of the results. And now to write it up in an APA conclusion, it's going to look something like this. So first, we state what kind of analysis we did. Since we're now dealing with more than one independent variable, it's important to say what kind of model we ran. And if you recall, the 3 by 2 refers to the number of levels of each of the IVs. So 3 different types of program by 2 different types of gender. And anyway, so we said here that an independent 3 by 2 factorial ANOVA analysis was conducted to determine whether program of study, so we have them listed here, and gender, listed here, influence reported well-being. So results suggest that we can reject the null hypothesis and that there was a significant interaction between program of study and gender. So here is the interaction F, or the F ratio for the interaction. So we have 2 and 12 degrees of freedom, and this value of 11 was bigger than the critical value for probability of 0.05, so it was significant. And we calculated the effect size for the impact of the 2 main effects, so gender on its own and program study on its own, plus the interaction, and we know that it accounted for 90% of the variance in well-being. So since I mentioned that we have this interaction, we don't care about the main effects beyond their contribution to this, and now we can focus on the simple effects. So an analysis of simple effects, including post hoc comparisons using 2 key HSD, where required, were conducted to determine the specific relationships between both independent variables. So specifically, the results suggested there were no differences between male and female engineers or between male and female psychology students. So we've reported the means for those 4 groups. Then for both male and female, for both males and females, psychology students reported more well-being than engineering students. So male science students reported less well-being there than female science students, where female science students reported similar amounts of well-being to female psychology students, and male reported similar amounts to male engineering students. So you can word this however you want, but the important thing is that all of the group means are present, and that you talk about the 5 different simple effects that we looked at. So you need to mention where there were non-significant simple effects, where the significant ones were, and since we have there were 6 cells, we need to have 6 different means and standard deviations in our conclusion. And then just a statement about the results. You can say female science students and both male and female psychology students reported more well-being than male and female engineering students and male science students. So that's kind of just the general conclusion. So now that you've seen an example, you can practice on your own. So there are 3 examples here that you can work on writing up on your own here. And then the examples of answers, or sample answers, or real answers, however you want to call it, are actually just here at the end. So you have 1, 2, and 3. So good luck with that. Pretty straightforward, similar format to what we've looked at so far this semester. Just remember that when you're looking at, or when you're reporting your group means, that you need to report based on whether or not you have a significant interaction. So if the interaction is significant, you're going to want to report these means here, so for each group and those ones there. If it's not, you're going to look at the total yeses, the total no's, and then the total very uncomfortables, uncomfortable, comfortables, and very comfortables. Okay, so that's important when you're looking at which groups you're actually comparing. Okay, thank you very much.